Hi, everybody. Good afternoon. I'm super excited to be here today. And we're going to talk about this topic that you would have definitely heard about, but maybe some of you know about it. And the potential it holds and the future it will unfold can have a massive impact on your life. So, just to get an idea, can I get a show of hands or a reaction in chat on how many of you are already familiar with blockchain? Ansh raised his hand, Mansi, Gauri, Divya, Raman is not Ravi. Okay, this is awesome. So a lot of you know, and for those of you who don't know, we'll fix this problem in just about an hour. So let me start by introducing myself. I'm Niharika, and I work with Decentology as a technical product manager. And I've been active in the blockchain industry since my own college days, which was back in 2017. I did my bachelor's from India and my master's from Switzerland, and that's where I am at the moment. And unfortunately, my colleague could not join me for this webinar. I don't know, he's probably in an emergency, couldn't reach him. So I hope he's all right. So he's Nick founded our company, Decentology, and I've been working with him since the last 3 years. And here's what we do at Decentology in a nutshell. Our company is headquartered in the beautiful city of Mountain View, California, and we're very passionate about creating products that simplify blockchain for developers. And it's ideal for developers who want to transition from Web 2 to Web 3. And we'll see in just a moment what this classification means. Our signature product is Dapp Starter, which we will take for a ride in just about a few minutes. And in addition to business, one of our core principal values is to create a more just, fair, and equitable world. And that's why we go an extra mile to foster gender equity. And here's what we're doing about it. So if you're a woman and you're attending this webinar, and you created a project with Dapp Starter, which I'll show you how to do in just a few minutes, you can win a scholarship to University of California, Berkeley's Professional Certificate in Blockchain Fundamentals. For this, all you have to do is write your full name in the live webinar chat and email a scanned copy of your college ID to scholarship@decentology.com. And make sure your college ID has the same name as you write on this chat. And we will then send you back a form where you will be asked to submit the project link. It can be a GitHub repository link, or if you have hosted it somewhere, that's even better. In that case, you can send both the links. And since Nick is not here, Vinayak, can you please keep a tab on chat and see if any girls respond? Yeah, Hemant, it's only for women. I'm sorry.
Yeah, absolutely.
Yeah, perfect. Thanks. All right, so let's get the show started. All right, so in this slide, what we see is a very high-level overview of the life cycle of a transaction on a blockchain. So someone sends a transaction to a blockchain, it's broadcasted to all the nodes in the network. And depending on the blockchain protocol these nodes are running, these nodes carry out various cryptographic operations to validate the block, and it gets added to the chain. And that is when the transaction is said to be settled or completed. And okay, so Gauri Singh, can you show the earlier slide, please? Yes, of course, Gauri. And I would recommend all the girls out there to probably take a screenshot of this slide. And I'm just gonna wait for like 10 more seconds here. I hope you were able to take a screenshot. Okay, so these nodes carry out various cryptographic functions, operations that validate the block, and then it gets added to the chain. And that's when the transaction is supposed to be completed or settled. And at this point, a very natural question should pop in your head. that where are these transactions really coming from? What's giving life to the blockchain? And the heartbeat of a blockchain comes from its smart contracts. A smart contract, um, a smart contract is simply a program that runs on the blockchain. It's a collection of code. That means it has a lot of functions, and it also has some data, which is known as state, that resides at a specific address on the blockchain. And in case of the Ethereum blockchain, it resides on an Ethereum address. So users can interact with the smart contract by submitting transactions that will essentially execute functions that are defined on the smart contract. So there are three things to keep in mind when programming a smart contract. The first is immutability of code. So when you deploy something on the blockchain, it's immutable forever. So you cannot change your code once it's deployed. So you have to be very careful, test it thoroughly before putting it on chain. The second is the cost. So every line of code that's executed on the blockchain has an associated cost with it. And the money that's paid, it's also known as gas, it's paid by the user. So if you have a function X on your smart contract, and let's say it has 7 lines of code in it, and as a very trivial example, I'm going to say each line of code takes $1 to run. So as a user, if I interact with function X, I'll have to pay $7 upfront for the transaction to go through. And if I pay less than that, then the chances are that my transaction will fail or revert. The third thing to keep in mind is storage. Storing something on the blockchain is very, very costly. So if your file is probably like 500 megs, you probably want to store it on a decentralized storage or somewhere else and not on the blockchain. It's going to cost you a fortune to get it there on the blockchain. So now with this knowledge, we have the tools to compare and contrast between the Web 2 architecture and Web 3 architecture. So what you're seeing on this slide is a very typical Web 2 architecture. It's a centralized architecture in nature. All the users, they send secure requests to the web server, which in turn sends a request to the API server, and in turn sends the request to the database server. And there's a whole bunch of give and take going on here securely. So in a nutshell, this is the Web 2.0 architecture. And I hope you're curious to see what Web3 looks like. And this is, on this slide, you see a decentralized architecture going on. Your client app can be hosted anywhere you want, but for the sake of Web3 ethos, it would be the best if you choose a decentralized hosting, platforms such as Fleek, IPFS, or Saya, or Arviv. And after a while, I'm going to paste the links in chat so you can check them out. I'm just going to repeat the names of the platform again. It's Fleek, IPFS, Saya, and Arviv. And if you just Google decentralized hosting platforms, you'll probably come across them. And your client application would be communicating with the blockchain constantly where your smart contract code is residing. And this is how typically a Web3 app works. And you'd be surprised to know that you already have plenty of skills to begin your journey as a blockchain developer. And the focus of this slide is to show you that if you already have a working knowledge of any front-end framework or library such as React, you already have 70 to 80% of the skills to be a Dapp developer. What you've got to learn is how to write a smart contract. And that can be done in many different languages. And you can, with trial and error, you can just see which one do you like the most. So if you're coding on the Ethereum blockchain, it's going to be written in Solidity. If you're making dApps on the Flow blockchain, your smart contract will be written in Cadence. On Solana, it would be in Rust. And on Quantum, it would be in TypeScript. And at this point, you're probably convinced that you already have most of the skills in your quiver. So you may be wondering, how much money do smart contract developers make? So if you're a good quality 10x developer, this is what typical blockchain salaries would look like. and it's a very lucrative career, and the promise it makes for the future, it's amazing. So it's like getting into computer science back in the 80s. So it's a very booming place, and I would really encourage all of you to check this out. And at this point, we will transition into a demo, a live demo of Dapp Starter, and that's where I'll tell you how to actually make the application. So at this point, I'm going to stop and see if there are any questions from the audience. Okay, so Garvit is asking, what's the salary in India? So Garvit, the way blockchain is working these days, it's the workforce is very remote. So I'm working with Decentology, which is based out of the US, but I'm working from Switzerland. So most of the jobs in blockchain are remote. So chances are that while you're in India, you would be employed with, let's say, somebody from Germany, and the salary you would be getting would be very competitive. So it kind of doesn't matter at the end of the day where's your location. They're not gonna dial down your salary based upon that. But yeah, so I hope that answers your question. All right, so yeah, you can get this PPT later. Um, if you don't know about blockchain, so how should we understand more about the basics, Corey? Um, One of the great places to start would be the scholarship that we're offering. So the professional certificate will give you, um, a whole bunch of fundamental knowledge about blockchain. So that's a good place to start. The other one would be if you just send it on, search it up on YouTube. And Arman, sorry, I missed your message. What languages we use for Binance BSC chain? So BSC chain is Binance Smart Chain, and it's a fork of Ethereum. So Ethereum's using Solidity. So Binance Smart Chain also uses Solidity. Rahul is asking, will blockchain's demand be still in the next 10 years? Absolutely. It's going to increase massively. The amount of talent we have in this industry is so scarce, and the amount of capital we have in this industry is so abundant. So if you're a good blockchain developer and if you know your stuff, yeah, your life is sorted, and your kids will probably thank you. Raman is asking, if the smart contract need that much money, how do we test apps within the blockchain? That's a very good question, Raman. So for the purpose of testing these apps, you can use test nets. So there's the main network and then there's a test network. On the main network, you're using actual real money. But on the test network, you're using fake or test money. And the other way to test your apps would be to run a local version of a blockchain, a local emulator, and that's what we'll do in a few minutes. So practically, you're not spending anything to test your blockchain app. Abdul is asking, is there any support for Cardano blockchain in your platform? As of now, no. Rahul is asking, will blockchain's demand be still in the next 10 years? Of course, yes. Garvit, how it's useful in AI? Garvit, this webinar is not about AI as such, but there are multiple use cases. You can look them up online. Arman, Rinkeby testnet for ETH. Yeah, Rinkeby, Robston, Goerli, there are many, many of them. So each of them is using a different protocol underneath. So whichever one you think is best fitting for your app, you can use that one. Priyanshu, Merkle trees. What's your question? I'm not sure. If you're asking what's the data structure, underlying data structure of a blockchain, yes, that's a Merkle tree. All right, what does blockchain mean? Okay, it's too late to ask about that. It's I would recommend you to probably just look it up. And just for the sake of this question, I'm just going to say that it's an immutable ledger. It's not a database. A database means you can store bunch and bunch of data here, But like I said, that storing anything on the blockchain will cost you millions of bucks. So it's not a database, it's a ledger, and it's an immutable ledger, and all additional transactions get added on it. And you already know how the transaction lifecycle works. So Ansh is asking how to get all the block headers in each blockchain to verify the blockchain hash. For that purpose, we'll be using the Web3 library, which we'll see in a second. And also, you can check out Ether's library. So these are two prominent libraries for that. Priyanshu, is it possible in blockchain to remove one or more blocks from the network? No, it should not be possible. But in theory, if you have more than 51% of the power over the network, you can still do that. So the more decentralized it is, the more nodes are running, the tougher it will be for you to compromise the blockchain. But if somebody makes up their own blockchain and has just one node in it, then yeah, probably you can take it over. Sort of, why is it so costly? Good question. Because so as of now, Bitcoin and Ethereum, they're running on these protocols called proof of work. And proof of work is a very repetitive protocol in which all the nodes that are participating in this consensus have to run the same transactions over and over again. And the cost of running these transactions, you have to use like really, really sophisticated ASICs chips, and which are like very expensive, and they use a lot of energy and electricity, and that's why it's so costly. Okay, so now I think you guys are talking to each other. All right, so if you have any more questions, you can also unmute yourself and ask the question. But this is really cool. I'm loving the engagement here. All right, so now we're gonna get into the demo. Please confirm when you start seeing my screen again. And when I switch to this demo, I won't be able to see the chat because my screen would be completely immersed with code. All right, so here we are. I'm at dappstarter.decentology.com. This is where you would get your full stack blockchain app. And what we have done is we have a whole bunch of blockchains here. And unfortunately, or fortunately, Cardano is not here. And we are supposed to be a blockchain agnostic platform. So if you want to insert your own blockchain within this code that we generate, feel free to do so. So for the sake of this webinar, I'm going to choose Ethereum blockchain. And as you can see, when I selected Ethereum, the language that it showed me came up as Solidity. If I had selected Solana, the language would be Rust, of course. So let's go back to Ethereum. And as part of frameworks, it asks me which front-end framework am I comfortable in using. So for the sake of this webinar, I'm going to use Vanilla.js. And the good part about the code is that all of this is written in web components. So technically, if you want to use React within this Vanilla.js app, feel free to do so. Angular or whichever one you want to use, feel free. Step 2, important part, smart contract features. So what we did was we abstracted a lot of design patterns and bundle them into these modules, smart contract features. So for example, if you want a feature in your app that gives you the ability to pause the operation of your smart contract, you click on this button here and enable contract run state. And a very good use case for that would be that you have your app running. Let's say it's a decentralized finance based app, and your smart contract has like millions and millions of dollars, and some attacker compromises the security of your smart contract and starts draining it off the contract. So at that time, what you want to do is you want to pause the operation of your contract. You do not want anybody else, any user, could be malicious, could not be malicious, we don't know, to be able to access your smart contract. So that's where we hit pause. So this functionality would be very helpful for that. The next feature we will discuss in this webinar would be the IPFS documents. So while I was telling you about decentralized hosting, I told you about IPFS, and we're going to use IPFS here, and you'll see in just a few moments how that's going to work. So all our files will not be stored on the blockchain, it will be stored on IPFS, and in turn, the hash of that file will be stored on the blockchain. So storing a small string is all right, but storing a whole image or something on the blockchain is not practical. And the third step would be you name your app. I'm just going to use a boring name, test, and then you click on create Dapp. And then what it's going to do in the background is create a full stack app, and it generates a unique GitHub repository for you. And if I go here, you'll see that it just got generated 12 seconds ago, and this is actually your full stack blockchain app. And all you have to do is clone it on your machine. So the way I would do is I would open up the terminal here, and I've already created a project just to save some time. So what you would do here is you would do git clone and paste your URL. And then the next step for that would be you would have to install some dependencies. So you would have to do yarn. So if you're a Web2 developer, you already know that you have to install a whole bunch of dependencies before getting started with the project. So the way to do that would be like probably npm install, but here for DappStarter, we are using yarn as our package manager. So like I said, for the sake of saving time, I already did yarn here. So it's already up to date. And for you, when you run yarn on your project, it's going to take about a minute or two for it to install all the dependencies. And for us to, actually fire up this app now that we have our dependencies in place, let me start this by using yarn start. And while this is happening, let me just quickly check the chat. What it says. All right, it's visible. Perfect. All right, so when I did yarn start, you see a whole bunch of stuff here. So what it's going to do is it's going to compile the smart contracts for you, deploy the smart contracts for you. And one of you asked a brilliant question about if it's so expensive, if the blockchain is so expensive, where are we going to use our Dapp? And it also started like a local blockchain emulator, which I told you about. So all the transactions we do right now, all the interactions with the blockchain are going to be completely free of cost. So it did all of that. It also has a beautiful client, which we're seeing right here, and it automatically pops up localhost 5000. So on your localhost 5000, when you run your app, you will see something like this. And essentially in this home page, you would remove all of this and put in your own application. And I'm going to start by showing you the UI harness. So in UI harness, you'll see all the smart contract features that we selected while creating our application. So we selected contract run state, and we selected IPFS documents. And you would see that there's an additional feature here, administrator role, and this got pulled in because contract run state is dependent on administrator role. So the code generator engine was intelligent enough to know which dependencies to pull from. And let me give you a quick demo of contract run state, which I was talking about, that you have the ability to pause or resume your operation of your smart contract. So we see two action cards here. The first one will tell you whether or not the contract is active. And the second action card will allow you to set the contract run state if you want to pause it or if you want to resume it. And one of the very important things to know right now would be that reading from the blockchain or querying the blockchain is free of cost. So if you're trying to get some data from the blockchain, it's free of cost. But when you're trying to change the state of the blockchain, when you're trying to write to the blockchain, it's going to cost you gas. So right now, if I click on view, it's not going to cost me anything. So I click on view and it says that yes, contract run state is active. So contracts are active as of now. And let's say that, some weird dude has compromised the security of my contract and I want to stop it. So here we see that there's a checkbox. It's a switch widget. So this is capturing a Boolean parameter, true or false. When it's checked, it's true. And when I uncheck it, it's false. So let me say that I want to stop the operations of my contract and I click on submit. And what happens is that I get this information about this transaction. I get the ID, I get the block number, and it also tells me which account was I using when sending this transaction. And here I also see a transaction hash. So keep in mind that this, let's do a quick exercise, OX532E. This is the beginning of my transaction hash. And on the right-hand side on Visual Studio Code, you see that this transaction hash, exactly the same one, OX52E, was run on the local blockchain emulator. And this is the amount of money that it used. And this is the block number. And this is the block time. So that proves that it ran on the local blockchain emulator. Now, if I click on view here, what do you think that the contract run state would say? Would it be active or would it be disabled? So maybe you can just write it in the chat and I'm going to go back and see the chat. All right, so Raman says not active. Arman says disabled. Disabled, Mansi. Perfect. You guys are like very smart. So yes, it should say disabled. So yeah, it says that the contract run state is not active. So at this point, if somebody tries to interact with any of the contracts that I'm hosting, they will not be able to do so. But for the sake of this demo, let me turn it back on. So I send another transaction to the chain and it's on again. So this in essence was contract run state. And now let's see IPFS documents. And here we're going to do a small exercise where we're going to upload an image to IPFS. So I'm going to upload this image right here, and I'm going to name it Michigan because that's where it is. And let's click on submit. So it's going to take a moment and okay, so it's already done. So what it did was it pushed this image to IPFS and stored the hash of this file on the blockchain. So here, if I cross this out, you would see you have this transaction and you would have the same transaction right here on the VS Code terminal. And you have your IPFS URL where you can access this. This is the hash of the file, QMNI, blah, blah. And this is the document ID, and it's going to be unique for each document that you upload. So if I open this IPFS URL, I would be able to see this image. And I'm going to share this URL with you, and you can confirm whether or not you also see the same image. So if you see the same image, you would be like this confirms that this image is hosted on a decentralized platform. So this image I uploaded is not an NFT, not at all, because if I have to make it an NFT, I'd have to use a different smart contract. Mansi, how to create a project with DappStarter. I just showed it to you. You go to dappstarter.decentology.com, and that's how you create your project. And Gauri confirms that she can see it. Raman, Subhadeep, Somanjali, Kedhareshwar. Sorry if I said it wrong. Sumit, Yashwant. Perfect, perfect. So you guys are able to see my screen, see this image. Perfect. Beautiful. So now if I want to query whether this image has actually been uploaded, I can again use the blockchain, or I could ask you guys. So a more efficient way would be to use the blockchain. So if I want to see if this document ID exists on the chain, I'm going to use this first function, get document. So I paste the document ID here and I click on view, and it returns a whole bunch of information. It returns the ID, it returns what label I use, it returns the Unix timestamp, it returns the address that I used to upload the document, it's going to return the digest, the hash, and all of that. So it says that yes, this document ID indeed does exist on the blockchain. And the third function here we'll explore is get documents by owner. So I want to see if I, as an admin, so all the documents that I uploaded were from my admin account. So this function will tell me what documents were uploaded by this account, admin account, and it should return me this one document ID. So this document ID is what Alice uploaded. And if I select, let's say, what did Birbal upload? If I click on view, what do you think it should say? I'm going to go back to chat. And if you see my screen, becoming infinite, I'm really sorry about that. So what do you think? If I query on the blockchain, if Birbal has uploaded anything, what should come up? Okay, so Raman says nothing. Arman, Subhadeep. And let's see whether Gauri says the ID of what? ID of the document. Well, we'll find out if Birbal has uploaded any documents or not. Utkarsh says nothing. So let's find out if Birbal has uploaded anything. And we get a null result back. And that's correct because Birbal has not uploaded anything. The document was uploaded from admin account and not Birbal account. So good job there. And now that you've seen the UI harness in function, I'm going to show you how to make this client your own client. So here, let me show you the file structure. So when you open your project in VS Code, this is what it will look like. And we will be working in the packages folder. And this package has 3 folders, client and dapplib. So all of our time we will be spending in the client folder and the dapplib folder. The client folder has all the source code for the front end of this Dapp. And this page right here, you see Dappiness. It's under source, pages, dapp.js. And if I change this Dappiness to, let's say, hello world, and save it, and it's going to hot load everything, so you don't have to stop the server and do anything. It's going to change it to hello world. And that's how simple it is to just change the client. As long as you know which web component is being used where, it's very easy to edit your client. And all the code that you see for the UI harness, there we go. For UI harness, for example, for contract run state, that will be found under this folder called harness. And I'm going to go on the contract run state harness. And this is where we will see the code for contract run state. And here I told you that we have 2 action cards. And these action cards are essentially web components. And each of these web components has a different property. So this action card has a title, which is here, is contract run state active. And if I just write something trivial here, let's say I add 4 dots and I save it, it added 4 dots here. And this is the description, the next line, this is the description. And a very important thing to here is action. So action tells this action card that which function should it call from the smart contract. So in order to do that, it's important for us to also see the smart contract of contract run state. And you can find that under dapplib, under contracts folder, under dappstate.sol. And this file is written in Solidity. .sol is the extension of Solidity. And if you create your own project and open this file, you'll see that it's very heavily commented. So you can just read it like a storybook. So here you see we have different states for contract run state. Here we are capturing the Boolean parameter for contract run state. Initially, it's set to true. That's why we see that initially it was active. Later you can turn it off again and back on again. So if we go to functions right here and we see is a contract run state active, this is reading from the blockchain and it returns a Boolean value. Okay. And here, if I go back to the UI harness here in this page, this function should be exactly identical to this function here. But an important thing to keep in mind is that your client is not calling the smart contract directly. There's a layer of abstraction, and that abstraction comes from dapplib.js. So within the source folder of dapplib, you have dapplib.js, and here you have this function called is contract run state active. So essentially, this line here in UI harness is calling dapplib, this function, and dapplib is calling the smart contract for you. So you're never calling smart contract yourself. And the way it's written here, the way dapplib is written here, it says that we want to capture the result and we await this asynchronous function blockchain.get, and we've tried to use some Web2 analogy here. So you can post on the blockchain and you can get from the blockchain, and in this case we are getting from the blockchain. So you remember that it's free of cost and everything. And here on line 24, we're writing the name of the function as mentioned on the smart contract. So this here should be exactly identical to this here. And if I go back to the UI here, this was the action property, which tells you which function to call. And the next property here is method. So method can be get or post. And for this function, it's specifically get. So when you use this action card, you will get this output. And it says that, yes, contract run state is active. The second one is a post method. So you have your second action card right here. And similarly, you have a title, description, action, method. And here you also have fields. So when you're posting something to the blockchain, it's possible that you have, some parameters to pass. And in this case, we wanted to pass the Boolean parameter, whether we want it switched on or off. And we're capturing that within mode. So in the smart contract, this function is written as set contract run state, and it's expecting one parameter, one Boolean parameter called mode. And in dapplib.js, we also have this function set contract run state, and it's posting something to the blockchain. And this is the exact name of the function as we saw on the smart contract. And the way to send this data onto the smart contract, you have to write this here. So data.mode will send over the parameters to dappstate.sol. Let's say you had one more parameter to pass. So you would put a comma and you'd write data dot whatever is the name of your parameter. Let's say it's parameter. So no matter how many parameters you have, you just keep on stacking them like this. All right, so this captures your field, and the way I told you that this is a switch widget, and that's also a web component, and it captures this field called modes. So here it's fields because an action card can have multiple parameters, but the switch widget can have one parameter, so it's field, and that's where a mode gets in. So it knows that, whatever switch widget it's capturing, it should be passed on to the action card. And that's how this works here. And here I will show you some more components you can use. So let me collapse harness in this. And if you open components, you'd see there's like a whole bunch of web components we've already made for you. Account widget, action button, this is the action button, action card, you've already seen that, and so many more. And I'm going to show you what's account widget. You can see it right here. If I go to UI harness, my PFS documents, and you see this account dropdown. This is exactly what account widget is. So I would recommend you to explore this more and make something of your own. And if you get stuck anywhere, I would also recommend you to join our Discord. And if you have any question, post there and we will be happy to help you through your project. And with this, I would conclude the hands-on demo and let's see if we have any questions. Yes, let me post the chat here, the link to Discord here. Okay, any questions? Yeah, and once again, I would request the women who attended this webinar to definitely try for the scholarship. Send over your college ID at scholarship@decentology.com and yeah, we'll get you going. And yeah, Lakshay, I think Vinay could help all of you get a recording. So as soon as it's available, he could send it to you. No, no, he'll not send it in Discord. He'll communicate with you all the way they have been communicating. And probably it's going to be uploaded on YouTube, so yeah, it would be open for all. All right, so if there's no question, I think we come to a logical end here. And it was really awesome meeting all of you, and I hope our paths cross again. And until then, take care and see ya. Bye.
Thank you so much, Niharika, for the lecture. What we can do is we'll share all the subject material with each and every one of them,
All
right?
right.
And I urge everybody to be in the Discord group. If you guys have any questions, please go ahead and ask them in the Discord group. Thank you so much for being here for your time, Niharika.
No worries. It was my pleasure. All
Okay,
right. Bye.
bye bye. Thank you, everybody. Have a good day. Bye bye.